area of a sector today, and when we're talking about the area of a sector, we're talking about this part here, this slice of pizza out of part of a circle. And so when we're talking about that part, we still have certain things that are true. This angle here is still theta. Our radius is still our radius, and our arc length is still our arc length. So if we are thinking about area of a sector, we're still going to be comparing it to the area of a circle. And so my area is going to be compared to pi times radius squared, because that's my area of a circle formula. And what we're doing is we're saying that's theta out of a possible 2 pi, because our theta is our angle of our sector, and 2 pi would be all the way around. So let's cross multiply and see what happens. So area times 2 pi is equal to theta times pi r squared. And if I solve for area, which is what I really want, I'm going to divide both sides by 2 pi, and I get area is equal to theta times, and these pi's are going to cancel out here, radius squared over 2, and the simpler way to write this would be 1/2 times theta times radius squared. So that's my area. And what we need to remember is that theta is going to be in radians, so we're always going to have to convert. Okay, so that's our formula for area of a sector. So when we get this example here, we're going to have our simple formula to say 1/2 theta times radius squared. Okay, so we're going to plug in what we know. Theta is going to be 1.4 radians, so that's going to go in here. 1.4, and our radius squared is going to be 2.1 squared. And when we simplify this down, we get 3.1 meters squared, because remember, area is always in square units. Okay, so that's pretty much how this works. It's a formula system, so all we're going to have to do is just plug in the pieces that we know. In this one, they give us the area of a sector. Okay, so they're saying if we have area equals 1/2 theta times radius squared, we're going to fill in what we know. Well, we know the area. It's pi over 3. We shouldn't be intimidated by that, because it could be pi over 3. That's fine. So the area is pi over 3. And this is going to be 1/2 times theta times radius squared, which we don't know. Let's jump over here for a minute. Our theta is equal to 15 degrees. Well, we need to convert that to radians. Okay, so I'm going to do 15 times pi over 180. That gives me 15 over 180 pi. So when I plug that back in, I get pi over 3 is equal to 1/2 of 15 pi over 180 times radius squared, because that's what I'm finding. I'm finding the radius. So I've got pi over 3 equals. Now, when I'm doing this fraction, what I'm going to end up with is pi over 24 times radius squared. Move up this way, give myself a little bit more space. And so when I go ahead and solve this, I'm going to divide both sides by pi over 24. So I'll divide by pi over 24, divide by pi over 24. And what you'll see happens is we have pi over 3 times 24 over pi, because we multiply by the reciprocal, is equal to radius squared. Pi's cancel. 3 goes into 3 one time, 3 goes into 24 8 times, so we have 8 is equal to radius squared. I'll take the square root of both sides, and I end up with 2 square root 2 is equal to radius. Okay? So that's pretty much it, guys. It's one of the two cases. Either we're finding the radius from knowing the area like we did in this, or in the previous example, we're finding the area. It's pretty straightforward. We'll see you next time.